Class scope. A reference variable follows the same scope rules as other variables. A member of a class is local to the class. You access a public class member outside the class through the reference variable name or the class name for static members and the member access operator dot. Methods and classes. Reference variables can be passed as parameters to methods and returned as method values. Recall that when a reference variable is passed as a parameter to a method, both the formal and actual parameters point to the same object. Definitions of the constructors and methods of the class clock. In this example, we now give the definitions of the methods of the class clock. Then we will write the complete definition of this class. First, note the following. The class clock has 11 methods. Set time, get hours, get minutes, get seconds, print time, increment hours, increment minutes, increment seconds, equals, make copy, and get copy. It has two constructors and three instance variables, HR for hour, min for minute, and sec for second. The three instance variables HR, min, and sec are private to the class and cannot be accessed directly outside the class. The 11 methods set time, get hours, get minutes, get seconds, print time, increment hours, increment minutes, increment seconds, equals, make copy, and get copy can directly access the instance variables HR, min, and sec. In other words, we do not pass instance variables or data members as parameters to these methods. Similarly, constructors directly access the instance variables. Let's first write the definition of the method setTime. The method setTime has three parameters of type int. This method sets the instance variables to the values specified by the user, which are passed as parameters to this function. The definition of the method setTime follows: public void setTime int hours, int minutes, int seconds. If 0 is less than or equal to hours and hours is less than 24, HR equals hours. Else, HR equals 0. If 0 is less than or equal to minutes and minutes is less than 60, min is equals to minutes. Else, min is equals to 0. If 0 is less than or equal to seconds and seconds is less than 60, sec equals seconds. Else, sec equals 0. Note that the definition of the method setTime checks for the valid values of hours, minutes, and seconds. If any of these values is out of range, the corresponding instance variables is initialized to 0. Now let's look at how the method setTime works. The method setTime is a void method and has three parameters. Therefore, a call to this method is a standalone statement. We must use these parameters in a call to this statement. The method setTime is a void method and has three parameters. Therefore, a call to this method is a standalone statement. We must use three parameters in a call to this method. Furthermore, recall that because setTime is a member of the class clock, it can directly access the instance variables HR, min, and sec, as shown in the definition of setTime. Suppose that the object myClock is as shown in figure 8-7. Consider the following statement. myClock.setTime 3:48:52. The variable myClock accesses the member setTime. In the statement my clock that set time 3:48:52, set time is accessed by the variable my clock. Therefore, the three variables HR, mean, and sec referred to in the body of the method setTime are the three instance variables of the object myClock. Thus, the values 3, 48, and 52, which are passed as parameters in the preceding statement, are assigned to the three instance variables of the object myClock by the method setTime. After the previous statement executes, my clock is as shown in figure 8-8. As you can see, the values of R is 3, min is 48, and sec now has 52. Next, let's give the definitions of the other methods of the class clock. These definitions are simple and easy to follow. Public int get hours, return HR. This will return the value of the instance variable HR. Next, public int get minutes, return min. This returns the value of the instance variable min. Public int get seconds, return sec. This returns the value of the instance variable sec. Public void print time. If r is less than 10, system.out print 0, system that print r plus colon. If min is less than 10, we print 0, then we print min plus colon. If sec is less than 10, we print 0, and then we print the value of sec. Public void increment r's. R plus plus. We increment the value of r by 1. If r is greater than 23, or if r is greater than 23, we set the r equals to 0. For example, if r is 24, then r's value is 0. Public void increment minutes. Min plus plus. It will increment the value of min by 1. If min is greater than 59, min equals 0, and increment r's. For example, if min is 60, then that is equivalent to 0 min, but we add 1 to r's by using the call of increment r's. Next, public void increment seconds. Sec plus plus. We increment the value of sec by 1. If sec is greater than 59, we set the value of sec equals to 0, and we increment the value of min by calling the method increment minutes. From the definitions of the methods increment minutes and increment seconds, you can see that a method of a class can call other methods of the class. The method equals has the following definition. Public boolean equals clock other clock. Return r equals other clock that r, and min equals other clock that min, and sec equals other clock that sec. Let's see how the method equals works. Suppose that my clock and your clock are shown in figure 8-9. My clock points to the object whose R is 12, min is 35, and sec is 48. Your clock points to an object whose R is 12, min is 25, and sec is 15. Consider the following statement. If my clock that equals your clock, in this expression, my clock that equals your clock, my clock here accesses the method equals. The value of the parameter your clock is passed to the formal parameter other clock. as shown in figure 8-10. Note that other clock and your clock refer to the same objects. The instance variables are min and sec of the object other clock have the values 12, 27, and 15 respectively. In other words, when the body of the method equals executes, the value of other clock that r is 12, the value of other clock that min is 27, and the value of other clock that sec is 15. The method equals is a member of my clock. When the method equals executes, the variables r, min, and sec in the body of the method equals are the instance variables of the object my clock. Therefore, the instance variable r of the object my clock is compared with other clock that r. The instance variable min of the object my clock is compared with other clock that min. And the instance variable sec of the object my clock is compared with other clock that sec. Once again, in the expression my clock that equals your clock, the method equals is invoked by my clock and compares the object my clock with the object your clock. It follows that the method equals needs only one parameter. Let us again take a look at the definition of the method equals. Notice that within the definition of this method, the object other clock accesses the data members r, min, and sec. However, these data members are private. So, is there any violation? The answer is no. The method equals is a member of the class clock, and r, min, and sec are the data members. Moreover, other clock is an object of the class clock. Therefore, the object other clock can access its private data members within the definition of the method equals. The same is true for any method of a class. The method makeCopy copies the instance variables of its parameter other clock into the corresponding instance variables of the object referenced by the variable using this method. Its definition is public void make copy, open parenthesis, clock, other clock, close parenthesis. Open curly brace, r equals other clock dot r, min equals other clock dot min, sec equals other clock dot sec. Consider the following statement. My clock that may copy your clock. In this statement, the method makeCopy is invoked by my clock. The three instance variables hr, min, and sec in the body of the method makeCopy are the instance variables of the object my clock. The variable your clock is passed as a parameter to make copy. Therefore, your clock and other clock refer to the same object, which is the object, your clock. Thus, after the preceding statement executes, the instance variables of the object, your clock, are copied into the corresponding instance variables of the object, my clock. Note that, as in this case of the method equals, the parameter other clock can directly access the private data members of the object it points to. The method getCopy creates a copy of an object's hr, min, and sec, and returns the address of the copy of the object. That is, the method getCopy creates a new clock object, initializes the instance variables of the object, and returns the address of the object created. The definition of the method getCopy is public clock getCopy, open and close parentheses. Clock temp equals new clock, temp.hr equals hr, temp.min equals min, temp.sec equals sec. Return temp. The following illustrates how the method getCopy works. Suppose that your clock is as shown in figure 8-11. Consider the following statement. My clock equals your clock dot get copy. In this statement, because the method getCopy is invoked by your clock, the three variables hr, min, and sec in the body of the method getCopy are the instance variables of the object your clock. The body of the method getCopy executes as follows. The statement in line 1 creates the clock object temp. The statements in line 2 through 4 copy the instance variables of the object your clock into the corresponding instance variables of temp. In other words, the object referenced by temp is a copy of the object your clock. See figure 8-12. The statement in line 5 returns the value of temp, which is the address of the object holding a copy of the data. The value returned by the method getCopy is copied into myClock. Therefore, after the statement in line A executes, myClock and your clock are as shown in figure 8-13.